So an interesting function that calls for discussion is the absolute value function. So the absolute value function. And the absolute value you know to be, you have seen many times before as the absolute value of -3 is +3, or the absolute value of some number is its distance from 0. So the number of spaces it needs to travel from -3 to 0 are 3 spaces, the magnitude. So the absolute value function, and the simplest absolute value function that we have, is f of x is equal to the absolute value of x. So this is the simplest absolute value function that we have. So we could draw a table of values. If we were given a series of x values, we could plug in the y values as a result. They would just be the absolute value of the input. The function itself is interesting as a graph because absolute value cannot be negative. The output cannot be negative. So when you graph it, it becomes quite interesting. So the f of x, the function of x, you can actually define it as a piecewise function. So this piecewise function can be, well, the absolute value of x is equal to the function just x when x is greater than or equal to 0. And then the function absolute value of x is equal to -x, the function -x, when x is less than 0. So let's see what that looks like. Let's see what that looks like. So I'm going to grab a different color here. And let's draw some axes. Got a y-axis. An x-axis. Okay. So when x is greater than 0, so here's our origin. When x is greater than 0, the function behaves like the function just x, y equals x. So let's draw that here. Okay, there we go. And then when x is less than 0, the function behaves like y equals -x. There we go. So this is actually what the graph of f of x equals absolute value of x looks like. It is a V-shaped. It has a single point, which is its minimum value, located right here at the vertex. So we can actually call this point the vertex point. And it is symmetrical about an axis. So in this case, it is symmetrical about the y-axis. And what this is called is the axis of symmetry. The axis of symmetry. Okay, so that is the general function for the simple absolute value function. let's discuss it a little bit more in depth. Because you're not always just going to have the function, change colors. You're not always just going to have the function y equals absolute value of x. Sometimes it can be translated in different directions. So being able to recognize these translations is fairly important. So a vertical translation is represented by adding some constant k. So a vertical translation in the up direction is y equals absolute value of x plus k, where k is greater than 0. K is greater than 0. So a translation downwards would naturally be y equals absolute value of x minus k, where k is greater than 0. Okay? So that is our vertical translation. Separate that off. We can also have a horizontal translation. Horizontal translation. And the horizontal translation, if we're trying to translate to the right direction, we could write this as y equals absolute value of x minus h, where h is greater than 0. So that h value is actually inside the absolute value sign. So it's x minus h, where h is greater than 0. So that would be translating this function to the right h units. So if we were trying to translate to the left, we would have y equals absolute value of x plus h, where h is greater than 0. Okay. So those are vertical and horizontal translations. There are more than just vertical and horizontal translations to a function. You can also stretch or compress a function. So if we were trying to stretch or compress the function, we could do that through, so if we were trying to stretch, let's start with stretch. This would be by actually multiplying our absolute value of x by some value a. So a times the absolute value of x, where a is greater than 1. So where a is greater than 1. Okay? And then if we were trying to compress, or trying to recognize a compression, this would be our parent function y equals absolute value of x, y equals absolute value of x times a as well, times a, times the absolute value of x, where a is between 0 and 1. So where a is some fraction, some decimal between 0 and 1. So that would actually compress our absolute value function. It would press it down. And finally, the last way that we can translate the absolute value function is through reflection. And reflection about the y-axis, reflection about the x-axis, we'll start with the x-axis. So in the x-axis, y is equal to negative absolute value of x. Negative absolute value of x. So that would be multiplying the absolute value of x by a value of -1. That would reflect in the x-axis. And in the y-axis, what we're going to do is we're actually going to take the parent function and we're going to place the -1 inside the absolute value signs. So it would be y equals the absolute value of -x. This would be reflection in the y-axis.